free to let us know where you're joining us from. That's always fun for us to see. This is a collaborative webinar series of friends from the field between Blue Hill Heritage Trust and Island Heritage Trust. My name is Jake, and for those of you who are just logging in, we're going to do some tech for the webinar, and I'm going to hand it over to Beth from Blue Hill.
Thank you very much, everyone, for joining us. We've got about 29 people or so who have tuned in so far. If folks would like to identify who they are in the chat, let us know where you're listening in from. That would be great. If you have questions for Abby, or it's Abby, right? Not Abigail? Okay, Abby. If you have questions for Abby during the talk, you have a couple of options. One is you can put it in the chat and we will get to those questions at the end. We'll have a Q&A. There'll also be an option for you to use your raise your hand tool at the bottom of the screen, and you can ask your questions yourself using your own audio. So both the hand raise tool and the chat box icon are at the bottom of your screens for you to use during the talk today.
All right, thanks, Beth. So I'm going to do our formal introduction. Today we have Abby Barrows joining us from Stonington. Abby is a local and has studied microplastic pollution in our oceans since 2012. And just to give you guys a little intro, microplastic pollution is considered an emerging issue and international concern. An estimated 8.8 through 10 million tons of plastic makes their way into our oceans and freshwater each year. It can be found in our bottled water, our beer, our honey, our salt, and even sometimes in our air. And today, Abby is going to shed some light on this very pressing issue for us. Abby, thank you so much for joining us.
Thanks for having us, for me. All right, I will share my screen and we can get going. Right, is that showing up for everyone? Right.
I don't have it just yet on my screen, Abby.
Okay, let me know. No, it doesn't.
I think if you click on the center in the bar, it should say, like, it's in green on my screen, it should say share screen, and then it gives you a couple of options. And generally speaking, you got it. There you go.
Great, there we are. All right, moving forward. All right. Thank you everyone for tuning in today for yet another Zoom meeting webinar. I'm really glad that you have the interest in this topic. So my name is Abby Barrows and I'm a research associate with the College of the Atlantic, and I work as a science research consultant. Today I'm going to talk about plastic pollution in general and my research pertaining to microplastic pollution. I'm going to throw a lot of numbers at you at first, and then I promise I'll do less of that. Okay, so the first fully synthetic plastic was Bakelite, and that was invented in 1907. And Leo Baekeland coined the term plastic. And there has been new plastic invented every decade since. And most plastic we use for just a few minutes before we throw it away. So this graph shows the cumulative production of plastic by the millions of tons every decade since the 1950s, which is when it really came into household use. So the black line is primary waste generated. The red line is all waste discarded or put in the landfill. The green line is all waste that has been burned. And the blue line is all the waste that has been recycled. The dotted lines are projections for into the future. So globally, we're producing around 360 million tons of plastic each year. And more than half of the plastics made have been made since 2005. And that's expected to double in the next 5 years and more than triple by 2050. So globally, as of 2016, about 80% of all plastics made was accumulated in landfills or in the natural environment. So this is a diagram illustrating the plastic waste generation in the United States and the estimated mass of plastic waste that was mismanaged domestically by littering and illegal dumping, and also sent abroad during the process of material collection for recycling. Only about 9% of post-consumer plastic is recycled in the US, and we are the second largest exporter of plastic scrap globally. It's almost always sent to countries that cannot adequately manage plastic waste. Globally, approximately half of plastic waste is collected for recycling and traded internationally. It's a big market. So it's not surprising that images such as these are becoming more and more common sights around the world. As Jake mentioned, around 8 million tons of plastic pollution come from land, and about 2.5 million tons come from rivers. So it's not just a coastal issue. To visualize that, think of 5 grocery bags of plastic on every foot of coastline around the globe. And by 2025, those 5 grocery bags of plastic are going to be 10. So if we continue on our current trend of production and mismanagement, it's projected that plastic will outweigh the quantity of the weight of fish in the ocean by 2050. So these 4 maps show model predictions of global plastic pollution density in our oceans. So each map shows different size classes of plastic with the size range on the bottom left-hand corner. The color bar on the right shows the pieces of plastic per square kilometer, with the dark red representing the highest densities. So the top 2 maps represent smaller microplastics and then larger microplastics. And then the bottom left is the mesoplastic, and then the bottom right is the macroplastic. So as you can see, microplastics are really dominating that map. And it's estimated that there are between 15 and 50 trillion plastic pieces weighing over 250 tons afloat in our oceans. And that's really just looking at surface data. Every aquatic habitat that has been researched has been found to contain plastic. So what are microplastics? They are a pollutant that has emerged as an issue of international concern. You know, when I first started this research, I would ask a room of people if they had heard of microplastics, and maybe one hand would go up. And now basically everyone's hands go up. They are defined as a piece of plastic that is between 1 micron and 5 millimeters. It's really important to think of microplastics as a suite or a class of contaminants, because microplastics are diverse. They come from many different products and polymer types, but they all have the shared characteristics of being non-biodegradable. They all absorb and release chemicals, and they fragment, but they don't disappear. They come in different shapes, sizes, and colors, with microfibers being the most commonly found shape. Microplastics have been found in all of the world's oceans, from the surface waters to the deep ocean trenches. They've been found in freshwater environments, snow, tap water, bottled water, all sorts of different beverages, honey, table salt, seafood, animals, human placentas, and our air. The more places we look for microplastics, the more places we're finding them. So there's 2 different types of microplastics. Each have different regulatory aspects. So the primary microplastics are these nurdles, which are these pre-production pellets, sort of plastic resin pellets, also called mermaid's tears in some places. These are transported around the world to manufacturing sites where they're melted and molded into the final product. Microbeads are also a primary microplastic. They're added into personal care products such as face wash, toothpaste as an exfoliant or a filler. These are now banned in many countries around the world, but they still persist in some wash-off sunscreens and pharmaceuticals. The primary microplastics directly enter the environment through spills in the case of nurdles, or through our household wastewater when we wash our face or brush our teeth with these products. Secondary microplastics are the predominant type of microplastic that we found in the environment. These are small pieces of plastic that come from larger pieces fragmenting over time, such as from bottles, bags, tires, textiles. This happens through mechanical and chemical degradation. Another significant contributor to the secondary microplastics appear to be our clothing. So each time we wear, wash, or dry our synthetics, so you think your yoga pants, your running shorts, your polar fleece shed into the environment, both in the water and the air. Each washing machine cycle can release thousands of microfibers, resulting in an estimated 500,000 tons of microfibers from synthetic clothing ending up in the sea every year. Also, when we dry them in our dryer, we're finding that that's releasing thousands of fibers into the air as well. So how did they get into the environment? Just touched on that a little bit, but point and non-point pollution sources for microfibers are similar to other pollutants. So, but especially noteworthy sources of microplastics are tire dust. So we all have to replace our tires every year or two. Where do you think all that synthetic rubber goes? And our wastewater from our wastewater treatment plants. Tire and road wear particles are emitted into the environment by the thousands of tons each year, and we still don't have a lot of research on that for the US. Wastewater treatment plants, depending on their design, they can be a major source of microplastics from domestic washing in both the outfall, which usually goes into a waterway, or the sludge, which is land applied. The sludge can also be landfilled, but it can contain really high numbers of microplastics and microfibers. And from this land applied sludge, those plastics can get into the groundwater or run off into the watershed or become airborne. Two other sources, point sources of microplastic pollution that are just beginning to be studied are airborne microfibers that shed while we wear the synthetic clothing. And the other potentially very significant source of microfiber pollution are cigarette filters, but their contribution is still yet to be quantified. So in the aquatic environment, there are many ambient toxicants, and most of these toxicants are known as the persistent organic pollutants, or POPs. It's a cute name for something that's really nasty. These are the compounds that are resistant to environmental degradation. They're called legacy compounds. The physical and chemical properties of plastic facilitates attraction and concentration of these chemicals, sometimes up to 1 million magnitudes higher than the surrounding seawater. Plastics also release the hazardous additives that they are made with into the environment. All of these chemicals have known negative and human and environmental impacts. So this tiny, seemingly insignificant piece of plastic can become a toxic sponge and transport POPs and their associated additives around the world and into different habitats and animals and humans. So unfortunately, when plastics are consumed either directly out of the environment or indirectly through consuming prey that contains plastics, some of the toxins from and on plastic can leach into the animal and find a permanent place in the food web. We've also discovered that microplastics can move through the blood-membrane barrier and enter into different body systems. Studies have shown associated behavior changes, reduced reproduction, energy uptake, diminished offspring performance in animals that have ingested microplastic. Ingestion can have long-term individual, population, and community level impacts that we're just beginning to understand. We also know that we are eating and breathing them in, about 0.5 pound each a year. But the impacts of environmental exposure to microplastics on mortality, morbidity, and the reproductive success of species and humans continue to be investigated. So to put it in a more local context, back in 2015, when I was with the Shaw Institute, I did a food web study. We analyzed 51 mussels, both rope-grown and wild, oysters, clams, lobsters, and mackerel. We found microplastics in 96% of the seafood samples. The average number of microplastics per gram of tissue across all the species was 2.5 pieces. The lobster and mackerel, not surprisingly, had more of the large microplastics, so between 3 and 5 millimeters, than the bivalves. So although microplastic research has been a really fast-moving field, there continues to be a lot of questions about sort of the short and long-term impacts. But one of the first steps in furthering my understanding was looking at how we collected and quantified microplastics in the marine environment. So I conducted a field comparison study on 2 different sampling methods. that were commonly used. This paper demonstrates that the traditional and most often used technique for sampling microplastics, the surface plankton net on the bottom right-hand corner, gave a density estimate for microplastics that was 3 orders of magnitude lower than this grab sample, which is just a jar of water that you scoop into the surface water. So relying solely on the Newston samples would have resulted in a gross underestimation of the amount of microplastic in the sea surface. Also, the grab technique lends itself to citizen science because it's easy to build in quality control measures, which is really important in this field of research. It has a simple protocol and the equipment is affordable. So once I had this solid methodology down, I wanted to learn more about the sources, composition, and distribution of microplastic pollution in the oceans, rivers, and lakes worldwide. So in 2013, I approached and partnered with an organization called Adventure Scientists. They're a nonprofit based in Bozeman, Montana, and we launched the Global Marine Microplastics Initiative. And in 2015, we expanded into global freshwater environments and also began a 2-year study in the Gallatin watershed in Montana. They primarily managed the citizen scientists, and I ran all other aspects of the project. At the project's conclusion, we made this short video that will explain more about the organization and the project. 5 years ago, we scooped up a half liter of water locally, brought it back to the Institute, looking under the microscope and seeing all these technicolored pieces of plastic led me to think of all of these larger questions. How is it affecting the ocean? Our drinking water? Are microplastics everywhere? But I couldn't answer those on my own. So this is when I partnered with Adventure Scientists. Adventure Scientists is a nonprofit organization that unites explorers and scientists to solve some of the world's most pressing environmental issues in which access to data is crucial to resolving them. I worked with Adventure Scientists to train adventurers who would be collecting data for me around the world. I'm about to take a microplastic sample. Able to get water samples from the Antarctic and the middle of the Pacific. We're going to send this into the labs. Through the process of working with Adventure Scientists, I was getting closer to understanding the magnitude of this issue. After analyzing thousands of samples from around the world, we concluded that 74% of them contain microplastic pollution. Microplastics are one of the largest pollution problems that you've never seen. Without Adventure Scientists, I would have never been able to even dream about this breadth of data that I've been able to collect. The Adventure Scientist model lends itself to so many different projects, whether it be microplastics or forestry conservation or animal protection. This is just the beginning. So based on our survey results after that project concluded, 80% of our volunteers have taken steps to address plastic pollution or microplastic pollution in their communities. And we're really proud of that it had sort of a wider reaching impact. Oops, there we go. Okay, so each point on this map shows where one of those 1 liter surface grab samples was collected by an adventure scientist. The size of the bubble indicates the quantity of plastic found in the sample, and the color indicates whether there was plastic found or there wasn't plastic found. So the orange ones are samples that contain plastic, and the yellow bubbles were ones that did not contain plastic. We collected over 2,400 samples, over 1,300 of those in the marine environment, and we found an average of 12 pieces of plastic per liter of seawater. And over 1,000 samples were collected in freshwater, and we found an average of 1.5 pieces per liter of water in freshwater. 90% of the microplastics that we quantified as microfibers. The majority of those were invisible to the naked eye, so less than 1.5 millimeters in size, which is a smaller size than those captured in the majority of surface studies. So at the project end, we produced this publication, which covered 5 years of marine research conducted in partnership with adventure scientists. It was really important to me to have the data peer reviewed in order to validate the research in the wider world and increase its impact. All of the data that we collected is open source, as are the lab and field methods. So for the marine findings in brief, as I said, we collected 1,393 samples from every ocean on the planet, including coastal environments and understudied ocean regions. The data showed that the microplastic concentration was higher in the open ocean than along the coastal environments, the highest concentrations found in the polar regions. This was further validated, or has been further validated by other studies. Spatially, microplastic contamination is very diverse, as you can see with the color bar here in terms of the amount of contamination per sample. So this is a picture that I snapped on the filter of a sample taken in the middle of the Atlantic Ocean. There's not a scale bar on here, but the one side of the grid is 3.2 millimeters long. So you can see that these are very small fibers. So to focus on the Gulf of Maine, we only had coastal samples, but we had the second highest amount of plastic of any region in the Atlantic Ocean. The Caribbean was the first. On average, we had 8 pieces of plastic per liter of water, and 96% of those were microfibers. In the freshwater, we had half a piece of plastic per liter of water, and 100% of those were microfibers, which makes me think that they're probably from airborne contamination. Friends of Casco Bay also collected about 30 samples down in southern Maine, and they had a lower marine average of about half a piece of plastic per liter. So there could be a lot of different factors at play in terms of seasonality and things like that that we still don't understand. So in 2016, I joined an expedition to map microplastics in the Hudson River, from the headwaters to Ambrose Light in Long Island Sound. We collected 142 samples, and we found 233 microfibers, and it had an average of 1 piece of plastic per liter. Subsequent material characterization showed that half of the fibers were plastic, while the other half were non-plastic, but of anthropogenic origin, which I thought was really interesting. I did this work with the Rosalia project. From this project, we created a heat map of all of the sampling locations and the average amount of microplastics per liter found at each sample location. Interestingly, there was no relationship between fiber abundance, wastewater treatment plant location, or population density. I really thought that maybe it would be this perfect heat map where it's like, where there's very little population at the Lake Tier of the Clouds where it started, and then increasing to the nice bright red as we went through New York City. But as you can see, that was not the case at all. But we did find that the Hudson River's watershed drainage area contributes an average of 300 million microfibers into the Atlantic Ocean every day. I also did a small study on plastic contamination in bottled drinking water for a nonprofit called The Story of Stuff. We looked at 19 different brands, and 18 of the 19 brands contained particles with an average of 8 pieces of plastic per liter of water. At the same time, a larger international study was being conducted, looking at over 250 different bottled water brands in 9 different countries. And they found microplastics in over 93% of their bottles that they studied, with an average of 10 pieces of plastic per liter, with one brand containing over 10,000 pieces. It's on the whole, bottled water has been found to contain about 22 times more plastic than tap water. So one more reason not to buy a single-use plastic bottle. So now what? I've just thrown a lot of sort of depressing information at you. Generally, complex problems need complex solutions, but maybe this isn't very complicated. Plastic is a material invented to last forever, and it no longer can be used to make products intended to be thrown away almost immediately, because as we look at our oceans and land, there is no way. If we make less, use less, then we'll have less pollution. It's pretty straightforward. We've begun to see legislation across the world and the nation pertaining to single-use plastic reduction. Here in Maine, we have Styrofoam Ban that's going to be enacted in July, as with the bag ban. It was supposed to happen last year, but with the pandemic, that got pushed to this summer. It's a good start, but we need to really implement strategies such as the extended producer responsibility and circular economy models. Upcoming legislation in Maine, we're going to have an EPR, extended producer responsibility bill, focused on package recycling. Also, Washington State has a full extended producer responsibility bill, and there is a federal bill moving forward called Break Free from Plastic Pollution Act, and it's setting requirements for producers related to waste and recycling of their products, and sets forth provisions basically for reducing single-use products as well as limiting plastic waste export, which is a major thing for the US. So basically putting more of the responsibility on the companies that are producing the plastic rather than just the consumers. But we know that plastic use isn't going to stop tomorrow. So we need to think about upstream solutions. This isn't only a waste management issue, it's a materials and consumption issue. So for us here in Maine, our ocean supports multiple active commercial fisheries, and fishing debris is commonly observed. So policies relevant to incentivizing the return of fishing gear may be most relevant for us. Generally, local knowledge and long-term monitoring strategies are critical to inform effective local solutions. It's not just one size fits all. And in the meantime, there are some tools out there to help physically remove plastic from the environment before it enters the open ocean, which then is a huge issue in terms of cleaning up. So on the top of here, we have trash traps and the trash wheel, which is pretty famous in Baltimore and the Costa River. They just remove some of the larger plastics. On the medium scale, we have these little trash booms and the waste shark, which is a remotely operated little vehicle that goes along the surface water and it gets some of the smaller pieces of plastic. We also have the sea bin, which is awesome. I would love to get one, a few around here locally. You put it in a marina and it's basically helps suck up any of the floating plastic trash or other trash, and then you just pull it out and empty it as it gets full. On the smaller scale, we have the Cora ball, which was actually developed by Rosalia Project after a Hudson River expedition. Something you put in your washing machine, and it sort of captures some of those fibers that would otherwise go out in the wastewater. We have the Guppy Friend, which is a very fine mesh bag that you can put your synthetics in when you wash them. It also is really handy for baby socks, so they don't get sucked out of your washing machine, I found. And the most effective way to reduce microfiber pollution from your washing machine is the Filtrol, which is made by a Canadian company that you actually manually put on the output of your washing machine. You sort of change the filter in or empty the filter in there, much like you do for your dryer. So these are actions that you can implement and help support, but ultimately it's our awareness of the threat of plastic pollution and our actions as constituents and consumers that will help create a future free of plastic pollution. Also, as an individual, you can follow the work and the bills put forward by organizations such as the Plastic Pollution Coalition, Five Gyres organization, Upstream Policy, which is based here in Maine, and Surfrider, to name a few of the many organizations focusing on reducing plastics. So I think that there is sufficient scientific evidence to begin mitigation now for preventing future sources of plastic pollution. And as a scientist, I think it's that continuing to study population level health effects of plastic interaction with humans and animals is really important. But I think we need to operate under and implement the precautionary principle now. So fortunately, there's growing awareness in many government organizations and in the general populace. All of you are listening today of plastic pollution as a threat to our health and our ecosystem. There's also international agreements and national action plans that can provide the foundational support for local investigations that lead to the implementation of science-informed actions relevant to each region. So much of my research shows the importance of local sampling campaigns to inform solutions on the ground and feed into global databases to better understand the issue on a larger scale. For plastic pollution, I think we need to think globally, collaborate globally, regionally, and nationally, and act locally. So thank you so much for listening, and I'm really happy to take any questions.
That was great. So we've had a couple of questions pop up in the chat. I think that most people were listening to intently to write, because I think there are some coming in now. The first question we had was that you had mentioned that you had seen evidence of microplastics in placental tissue. So the question was, are you also finding them in fetus and neonatal tissue? And then I also wanted to add to that, I had also heard that it can be found in breast milk, and could you verify that as well?
Sorry, could you repeat that last piece?
I had heard that you could find microplastics in breast milk. So my question was, in addition to the fetal and neonatal tissue, is it also found there?
Yes, so actually a study just came out, I think like 2 weeks ago, the first evidence of microplastics in placentas, in human placenta. The study was relatively small, but it showed that there were some diverse microplastics found on both the fetal and the maternal side of the placenta. But beyond that, they didn't really measure toxicity and things like that. It certainly has been found in breast milk, and milk in all mammals is sort of a vector for toxic loading and dumping, right? A lot of the toxicants in our body end up in our breast milk and then are transferred to the children, babes. So yes, it's major, potentially major finding to see how microplastics are moving through the blood membrane barrier, and what still to be determined what the toxic fingerprint and legacy is being left behind through this.
Okay, and then you had showed there's a lot of interest in those products that you had shown on the screen having to do with laundry. And so we had someone who asked, where can we get those items? And then someone else who asked if you would provide links for us to share with them after the fact on where they could get those products.
Absolutely, yeah, I'd be happy to. And some of those resources as well for learning more about plastic pollution.
Thanks, Abby. I have a question for you. And first, I'm gonna take this off out of respect for you, because I'm the poster child for synthetics right now. But I was so happy to see that you provided some those links for those products that we can purchase, because I think synthetic clothing is just unfortunately a necessary evil in this modern life. So it's great that there have been developments made to kind of, balance out what's going into our water. I have a question for you about the plastic bag ban is coming to our local area in July. And one of the things I guess I hear against that is that the paper bag alternatives require more carbon emission to manufacture, and like, how is that being offset? And is there a simple answer to that, or is it just part of a huge complicated discussion to be had?
we could have a whole webinar around that, but the short answer, well, is sort of, I'll answer that in sort of in two parts there. What's most recommended for bans is to ban all takeaway single-use bags. So that's plastic and paper, and really start to move towards a reusable society. So bring your own bag. The paper, I think, I look at it as the lesser of evils. It does not have, yes, it might cost more to transport, but the oil extraction used for plastic bags and every single step of the life cycle of a plastic bag, doesn't even compare to a paper bag. Paper bags also, you can put them in your garden if you want to, or reuse them in a way that plastic bags just have such a continued toxic legacy. So yes, I think moving towards reusables, if we need a stepping stone for paper bags in some communities, that's at least a step in the right direction.
All right, I will be better prepared when asked that question next time. Thank you, Abby. There was a question, let's see. Is the US among the countries that have banned plastic exfoliants in skincare products?
Yes, that was one of the last bills that Obama signed into law before he was finished. And that was the what was it called? The act to ban microbeads. So yes, it was a fairly comprehensive legislation, but some things slipped through the cracks. And I think with some of the plastic focused bills that we'll see in the next few years might try to capture some of those items that didn't come under that legislation. So there's been quite a sea change with that all over the world. Europe was ahead of us, of course, in banning that. So I think soon those sorts of products will become more and more obsolete because they're not accepted in so many countries. And we also know that there's so many wonderful alternatives for exfoliants that are byproducts from other industries. So that was a low-hanging fruit, if you will, for reducing plastic, washing off plastic into our waterways.
And I just have one follow-up question on that, Abby. I see walnut in a lot of the products that I use. Is that like a good thing, or?
I think so, because I'm assuming that they're not throwing away the walnut meat. I think that a lot of that comes from shelled walnuts that are put into other products, and that's just a byproduct. Same with coffee grounds or apricot pits and things like that. I think it's a great use.
So we had a comment from Cynthia. It looks like Deer Island Stonington High School is working on reusable sewn fabric bags as part of their eco club, and we'll be placing them in stores on the island. So that's good. We can support our local eco club, and there'll be some reusable bags available in I assume on the island, but maybe even further out. So that's good.
Excellent. That's good. That's really good news, because I think it's it's changing behavior, and that takes time and remembering. And I think having those alternatives close at hand helps that transition, makes it a little less rough.
Abby, can you speak to whether or not there is any alternatives to plastic packaging for meat? We've got a few people who asked about that.
This is sort of have a bone to pick around this, no pun intended, that there's been a lot of R&D around alternatives to plastic, but there hasn't been one plastic that has, or alternative to plastic that has sort of stepped into the role that plastic fills as we know it right now. So I feel that if we had a little bit more, it's a critical mass thing, right? We need to have the interest, the consumer interest, the policy, all of those things behind driving a new research and development for alternatives to plastic. So at this point, I wouldn't name one thing that is the surefire thing for packaging meats and fish and things like that. But the technology it's getting there. It's a little slow, but there has been some interesting things using algae and chitin from as a byproduct from shrimp and shell fisheries that I think are really interesting and exciting. But again, getting them competitive enough with plastic in terms of pricing is the next step.
Thanks, Abby. We had Stephanie was highlighting that Hawaii has signs like often warning about the plastic contaminants and fish and how there's coral killing attributes in sunblock and ingredients. And she was kind of noting that this should be more like put forward for knowledge in every state.
Yes, yep. Seafood definitely gets the brunt of the being associated with plastic ingestion. And we absolutely know that there's plastic in our seafood, but that's really the first animal that marine animals have been the first animal that has been studied looking at plastic ingestion over the last, since this is still a really new field. But the more we look in other animals, we're also finding comparable microplastic ingestion. Again, we still don't know what that toxic legacy is that the plastics leave behind. In terms of coral, yeah, I think Hawaii has banned most sunscreens that contain titanium dioxide and some of the things that are known to sort of smother a coral. And yeah, more awareness around that, and also just talking to people about that sort of thing. Again, the research there has to be good science behind there, but I think there is some solid research on the sunblock piece of things. And this is a really fast-moving field. Even though there's a lot of gaps, there's new stuff coming out all the time.
Abby, is there any research being done to correlate the plastic with any specific health ailments that you know of?
Well, we know that although, microplastic, the health effects of microplastics are largely unknown still, we know that plastics have endocrine disrupting effects, which means they alter the way that hormones normally function in a body. So although there's not a smoking gun, because we interact with plastics in so many different ways, not just ingesting them, it's really hard to pinpoint exactly what interactions are causing some of these things that we see that are common issues of our human health. But maybe it's a leap, but I think that if we know that plastics are made with hazardous chemicals, many are carcinogenic, and we, I'm touching it right now on my computer, we have such an intimate relationship with plastic. It seems that hopefully soon we'll have some research that will show that there are some correlations, because it seems to me sort of like a no-brainer, but the research just hasn't been done on any sort of scale that, allows me to make a bold statement there.
And on the topic of human health, Megan asked us if you could speak to the role of COVID in the exposure of single-use packaging, restaurants, school lunches, and maybe the rate of transfer on such surfaces.
Yes, so two parts there I want to touch on. One is that the CDC has found there has been no known cases of COVID transferred via surface, thinking about single-use or reusable plastics. And so that's really important when we think of, in the first few months of COVID, we really didn't know and just seemed like the safe thing to do. But now that we've learned that there isn't this transfer in the way that we thought there was, it's aerosol, that the single-use plastic has sort of become a runaway train, fueled by the plastics industry, because they have been making a lot of money through the single-use plastic sales. Also, we know that eating hot foods out of plastic really loads those plastic chemicals into the food. So again, it's really hard to tease out and pinpoint that directly as a human health effect when things might turn up down the line, because of that contact. There have been some studies, and I actually haven't dug into them too deeply, but just using plastic masks and how much more plastic people are breathing in. Right now it's estimated, pre-COVID, it was estimated that we were breathing in about 0.5 pound of plastic each year. And so it's a toss-up. You know, if you're wearing a plastic mask, are you breathing in more of the plastic from the mask, or are you breathing less in from the air? I don't know, but we do know that the personal protection equipment is washing up on all the beaches everywhere, and it's sort of this sweep of single-use plastic that is, you know, spiking in terms of our pollution in our environments because of COVID.
Can you speak to whether or not plants are also taking up nanoplastics when they grow?
So I didn't go into nanoplastics, one, because it's not my expertise, but two, that's a whole nother talk. Nanoplastics are sort of the next new thing in this field, and there's more and more studies coming out, but they're pretty scary because the way that they can be transferred, and they certainly are being taken up into plants. They're, you know, we know that the smaller microplastics can pass through the blood membrane barrier. We also see that in plants, but the nanoplastics, still to be determined what those long-term effects are and how long they reside, if they are being moved around or what. There's a lot of question marks in the nanoplastics field still.
Abby, we have viewers from all over the place. I just want you to know that, international, but we have Susan asking and commenting on Germany implementing a law where manufacturers are responsible for the external cost of their packaging. They must pay these costs up front. And she was wondering, as a scientist, if you've heard anything about this being implemented in the US.
So yes, I touched on that briefly. That's part of that would go under the extended producer responsibility umbrella. So basically trying to put some of the responsibility of dealing with the cradle to grave of this product on the producers. So yes, there is, I don't know when it's coming up, but there is the Break Free from Plastic bill coming up in Congress in this next year. That has been a lot of nonprofits have been working really hard on getting that language really tight and having that bill have some serious teeth in terms of putting responsibility where responsibilities do. But you know, the first EPR bill that ever was adopted in the US, to my knowledge, is the bottle bill, which we have in Maine. You know, it's returnable bottles. It's not plastic, but it's that same idea of being able to reuse and incentivize people to upcycle, or at least recycle, not downcycle, our products.
And Abby, we have someone on who is studying microplastics in freshwater invertebrates, who is from the Czech Republic. I'm not sure where she's listening from, but she said that they found lots of microplastics. They're trying to find the best way to separate out biomass from microplastics and how to count them. And she said, have you done something like that? And she wanted to also add in that the presentation is amazing. Thank you.
Yeah, that's really interesting, the macroinvertebrate and microplastics. I know that there was a study that came out that showed that caddisflies were building their houses out of microplastic instead of the little pebbles and stones that they usually glue together for their house, which was horrifying and fascinating. In order to separate, there are a lot of different techniques. I'd be happy to shoot an email to Helena about that, because that could also be a talk in and of itself. But there's a lot of different techniques for either digesting or doing density separation to try to get that plastic to float out of the matrices that you're working in.
Excellent. We'll make sure you guys have contact information.
Abby, it's starting to sound like we're going to have you back for another talk after oyster season with all of the follow-up questions. Cynthia was commenting on the plastic industry, and this is a kind of ongoing conversation since the 70s. And is it true that just plastic numbers 1 and 2 are recyclable?
The recycling conversation is also a really big one. So PT, number 1, is definitely the most recyclable type of plastic, but 1, 2, 5, HDPE, they're all recyclable, but on different levels, and how many times you can recycle them depends on many different factors, some of which there's dyes or colors or additives. Most often, and that's the biggest takeaway with plastic recycling, is we've sort of been sold a lie. Americans love recycling. We always want to recycle everything from our plastic tubs that we get our greens in, and to our bleach bottles, and so many of those things just are not recyclable, or it's not economical for them to be recycled. And so basically, recycling has continued to be put forward as a solution to the plastic pollution, and we know it's not. We can't recycle our way out of this problem. We need to think about viable alternatives to plastic. So the PET bottles, yes, they could be recycled, HDPE, polyethylene, but if they are is another question. Once again, it's less than 9% of the plastic used in the US each year is recycled. And a lot of that is shipped and finds its way into our environment. There's two different types of plastic, the thermoplastics and the thermosetting plastics. So think about like epoxy or resin, and they're hard, right? Those can't be recycled. The ones that are more malleable, that can be melted down at different temperatures, can be often recycled with other plastics of that same type. But again, how many times can they actually be made into something else before they sort of the polymers become weakened, basically?
And there was another part to Cynthia's question. She was wondering if as individuals, if there's any way for us to put pressure on the plastic industry for accountability.
Yeah, I think working with some of these organizations that have really made it their mission to try to make the upstream, look upstream to where the plastic's coming from. I think there's a lot we can do as individuals, as consumers. We can vote with our dollar to a certain extent, support your local bills, even spearhead local bills. There's a lot of information on the Plastic Pollution Coalition website and Surfrider websites to say, hey, you want to spearhead a bill or an ordinance in your town? Here's all the information on how to do it. Here's the letter to the, whoever, and these are the things that, does this work for your community? So there are a lot of resources out there to empower an individual, and there's also a lot of organizations that you can piggyback on with and help support some of the legislation that they're putting forward.
Abby, we have someone listening from Guatemala City who is studying to get his master's in sustainable tourism, and he is just asking if the research that you quoted here, your peer published research, is that available for people to look up online or in another location?
Yep, I have some of it available on my website, abbybarrows.com, and also my ResearchGate profile, and I'm also happy just to send along the PDFs as well.
Okay, great.
And a couple of folks have asked if this is going to be recorded and shared, and with Abby's permission, we'd love to put it up on both of our websites. It'll be on the Blue Hill Heritage Trust YouTube page, and we'll circulate it and get the word out as much as we can. Let's see. We have time for just a couple more questions here.
Sorry, I realized someone sent in a question before the talk began, and it was something I hadn't been asked before, so I thought I'd share it, even though I don't have a great answer to it. The woman was asking about acrylic paints, and we've all painted, and we know that for water-based paints, you wash the brush in your sink. And those are water-based paints, and so a certain amount of that breaks down, but they are acrylic, which is a synthetic. And thinking about that in our septic tanks, or if you're on municipal water, wastewater, that sort of thing, I do not think is trapped. And that's absolutely another source of paint is another source of plastics in our oceans. And I had seen a study done in Korea looking in a harbor, and the surface microlayers, that very top few millimeters of the surface of the ocean, which is actually where a lot of plastics hang out. There are lots of paint chips in there. And I always just thought, oh, it's sloughed off the boats, the bottom fouling paints and et cetera, which probably a lot of it has come from, but it also could come from industrial painting and domestic painting and washing of brushes, and that making its way into the ocean. So just when you thought we had tapped out all the potential sources of microplastic, we'd find another.
I'm glad you brought that up because that is super interesting. You don't think about that, those little day-to-day things like that. It's
Wash
amazing.
it down the drain.
Mhm. Let's see. We've got a lot of praise in here for you. I'm just kind of sifting through, trying to find some final questions here. Let's see. I believe that there's a belief here that the recycling business must be profitable in order to render a potential recycler willing to undertake such a business. Interesting. It seems to me that we need to find a standardization for nationwide recycling program.
Mhm. Yes, yep. And I know Eco Maine does a lot of work down in southern Maine on sorting plastics. Actually, they use a lot of incarcerated people to sort plastics along the line. But still, a lot of that, if it's a little bit dirty or it's a much more complicated process than just putting those things in the right bins at the dump. And yeah, again, it's often depending on the price of virgin plastic that directly impacts recyclers' purchasing power. So often virgin plastic is actually cheaper or comparable to recycled plastic, and producers will go with the virgin plastic because it's untainted and they can get the colors they want more easily and it's not cloudy, etc.
That's something I haven't thought about, is like the alternative of just starting fresh, whereas using recyclable goods. That's interesting. It's interesting. Beth, do you want to ask, maybe just you could pick one more question to ask, and I think maybe we can get through all of them.
Hold on here. Let's see. Someone had commented that Paramount Plastic product in Orono is focusing on creating a plant-based packaging to protect oceans. Still producing single-use disposables, perhaps a stopgap measure while we're being, retrained on how to, how to make better choices versus going to the plastic in the first place.
I'd be very hesitant. I love, in theory, I love the idea of plant-based plastics, but in practice, they're rife with issues. There's a lot of greenwashing that goes on around bioplastics or compostable plastics or biodegradable plastics. So to break it down a little bit, compostable plastics here in the US, for the most part, only can be composted in a high heat facility that requires very high temperatures for multiple days at a time. So that needs to be sorted out from the trash, and we don't really have other than bringing it there yourself, I'm not aware of any programs locally to capture that. A lot of the plant-based plastic also still is made with the same suite of toxic chemicals that are associated with traditional plastics. So they might fragment faster, but they're actually releasing those chemicals more rapidly into the environment. Also, a lot of the plant-based is corn, and there are a host of environmental issues associated with using corn, growing corn for plastics from, well, that's another whole conversation, but everything from the environmental impacts to using a food source for packaging. Most plastics that are touted as biodegradable actually do not degrade in the ocean. Five Gyres organization has done multiple studies, and they have the ban list 2.0, and they sort of go through all of the different bioplastics and compostable plastics and sort of rate them, and it's sort of a guide to help you as a consumer navigate what is now a very complicated process for people who want to do the right thing. I will actually be doing a little study with Five Gyres looking at some of these PLA and biodegradable plastics, or things that are touted as marine biodegradable, and we'll be doing a study here on Deer Isle in the coming months to see what does that look like after it's been hanging out under a dock for 6 months. And so that will help inform some consumer choices around what are some of the lesser of the evil choices to make.
Well, thanks for doing that work for us, Abby. Somebody's got to do it. Beth, I never asked if,
People's best.
yes. Beth, I never asked if anybody had raised their hand, if anybody wanted to ask their question to Abby directly.
I don't see any. Oh, wait a minute. I do see 2 hands are raised.
And don't feel bad if you did it by accident. It happens almost every single time. So you
Okay,
can,
so Barbara Putnam has her hand raised. So Barbara, I'm going to allow you to talk at this point if you'd like to ask a question.
Hi, Abby. I actually was trying to ask the question, and I was part of that data of almost every time that Jake is talking about. And you answered my question about plants taking up plastic, but this is fascinating and there needs to be much more study. Thank you.
Thank you, Barbara.
thanks, Barbara.
Okay, and then the last hand, another one has come up since then too, but Roger and Judith Doherty have got a hand raised, so you're unmuted. You need to unmute if Roger and Judith, if you're asking a question.
Yeah, okay, fine. I was going to ask, well, how long do natural fibers last in the ocean? Cotton, wool, silk?
That's a great question. So I didn't get into it on my study, my global microplastics initiative, but we actually did find quite a bit of wool and cotton in the middle of the ocean as well. And what you have to remember is that a lot of our fabrics are treated with all sorts of fairly nasty chemicals to help them persevere and have the properties that we want. I think I don't have numbers right off the top of my head, but if you would compare natural wool and microplastics and lay them down in a set environment, I think that we would find that the wool would further break down fairly rapidly if it was subjected to sun and salt and tides and things like that. Or also, if you just lay them out on the grass, what would be there in a year, what would be there in 3 years or 5 years or 10 years? The plastic would far outlive the natural fibers. But again, they also can be a vector for transporting some of those chemicals that we don't really want in our environments, in our animals, in our and humans.
And we have the last question here from Ann Lusky. Ann, I've given you permission to talk if you unmute yourself.
Thanks. Hi, Abby.
Hi, Ann.
Thank you all for having this. This is great. I always learn so much from you, Abby. It's awesome. And I have a million questions, but I'll just keep it to one. I'm really interested in learning. There's been so much progress over the years, and it's all incremental. And I think probably the impact of microplastics and plastics on, human health is probably around the corner. Have you come across people or organizations that are doing that work at the moment? Like how long are we going to have to wait before we understand, just how much this is impacting our own health?
That's a great question. And I wonder it myself. I was sort of surprised that when this first sort of hit the scene back in when it became more widespread in 2014, that there wasn't a quick smattering of studies relating to human health. It's been a little sluggish. And I understand because it's hard to study humans. There are a lot of different people around the world. I can't think of one organization in particular. It seems like a lot of universities are studying human health, and it's sort of this marriage between ecotoxicologists and people who study anatomy and physiology. So it's sort of pulling different people into the field of research, which I think is exciting. There are more and more papers coming out. As I mentioned, the placenta study just came out. There was one about microplastics in human feces in this past year. I think in the next few years, we will start to see a lot more research, probably from different organizations or funded by government, maybe in Europe, focusing on what what are those tangible impacts? What does that look like when it interacts? What do our cells look like when microplastics are interacting with them and passing into our blood? How much do we retain when we eat a credit card's worth of microplastics in a week? I'm hoping that there will be some much stronger correlations between the impacts, or maybe there won't be. Maybe we'll find that microplastics are actually pulling toxins from our body. But just seeing how the little bit of research in the marine environment on marine animals, it doesn't look like a very positive positive outcome for our research. But I'm hoping soon, and I think this year actually might be a big one for figuring out some of those questions.
Thank you.
Thanks, Anne.
Thank you very much, and thank you, Abby. So I think it's 5:07 according to my my time here, and I think we've gotten through all the questions. So I think we can wrap this up.
Yes.
On behalf of both IHT and BHHT, I'd personally like to say thank you. I thought I knew a lot about microplastics, and I learned quite a bit. So thank you.
Abby, thank you so much for being here this afternoon. And I hope that I should have plugged this in the beginning, but just so everybody knows, Abby runs and operates an oyster farm here locally in Stonington on Deer Isle. And maybe when she is done with her very busy season, she can join us again in the fall if she's willing and answer more of these important questions that we have.
Absolutely. Thank you for having me. And thank you everyone for tuning in and listening and your thoughtful questions.
Thanks, Abby.
Sure.
Thank you.